In this video, we're going to go over device-specific tabs. So first, I'm going to select the MAX15301 tab. And as you can see over here, there are multiple underneath tabs: Configuration, Monitor, Fault Set, Pmbus Commands, Permissions, and Tools. The first one, Configuration, has commands that have to do with configuring the device. You see over here basic settings. You have your vout command, vout margin high, vout margin low, your switching frequency, overcurrent, power good on, power good off, and you can change these values accordingly. Over here we have the startup and shutdown times. This is similar to what we saw in the dashboard. Over here we have the operation mode. This has to do with operation command and config command and how they work in conjunction with each other. This should be explained in the Pmbus user guide for those two commands. Down here we have store and restore commands. These are standard Pmbus commands, well, except for one of them. Restore maximum all is a maximum specific command. And by selecting one of these commands, you can perform this operation. For example, let's say that I change my vout to 1.1 volt and I want to store it, so I just send a store user role to store that command. If I want to get back to where I was before, I'll just send a restore user role. Over here on the right-hand side, we have the telemetry. This is similar to what we saw on the dashboard. So you see all the value being changed, and these are read-only. And over here we have some calibration commands. We have external temperature calibration commands and the current IOUT cal gain and IOUT cal offset. We also have some advanced configuration. We recommend that the users not change these. These are set to optimal for the device, and unless we need to change them, these stay as they are. The two buttons here at the bottom, Save Configuration File and Load Configuration File to Device, these are similar to the ones we saw in the dashboard. The only difference is when you click on the Save Configuration File here, it's going to save the configuration for this device only and not any of the others, as opposed to the dashboard save configuration where that saved configuration for all the devices. And the same thing goes for the load configuration file to device. If you load the file, you make sure you load the file for that specific device only. The next tab is the Monitor tab. This tab here, I'm going to stop it over here. This tab here basically gives you plots for your vout command, for your VN command. This is read VN, read IOUT, and for your external temperature. It also gives you the min and max for each of these. On the left-hand side here, it shows you the values of on-off config, vout command, vout max, IOUT cal. Over here, there's the telemetry, and here at the bottom, the status. It shows you the faults and warning. If there are any warnings, you'll see these green LEDs turn into yellow or orange. And if there are faults, you'll see these will turn into red. And in the next tab, we can look into these in more details. So the next tab is the fault set. In the fault set tab, we see on the left-hand side here the faults and warnings for vout, IOUT, VN, temperature, power good, and both on and off. And we see here in the middle there are limits where you can see they set the values for limits. Like, for example, if you set power good on to 0.8, that means if your vout is over 0.8, then the power good on will be on. If you set your power good on to, let's say, 1.5, and then your vout command is only 0.9, then this will be red because the device will not turn on. So basically, you play with these values over here. You can set them higher or lower, the limitation of the command in question, and according to that, you'll either get a fault or get a warning. In the middle here, we have the command responses, and these are explained in the Pmbus document, all the different settings. On the right-hand side, you have other faults. These come from status word, status byte, and so forth. And you can click over here on this view fault bit by bit, and you can see all these commands, and then the bits in each one of them, and the name for each of the bits. So basically, sometimes when you get a fault or a warning on the higher level over here, and you don't know which bit is creating the fault, so you can always select view fault bit by bit, and you see over here, and it will point you to the right problem. Like, for example, vout over fault. If this one is red, that you know that your vout is more than the margin high, or in some cases more than the vout max, if the device allows for the vout to be more than the vout max. And once you fix these faults, you can select clear fault warning, basically to get rid of the faults. The next tab is Pmbus Command Tab. This tab is available in all devices, and basically this tab is created dynamically. What I mean by that is when the GUI starts and the bus is scanned and the devices are found at specific addresses and identified, each of these devices has an XML file that is associated with it. And these XML files are part of the installation. And the XML file for a specific device will have all the Pmbus commands and the manufacturer commands that are supported by that device. And they are grouped in that XML file by functionality. As you can see here, the configuration parameters or commands are listed over here, and then the fault ones are listed in under a different tab. The monitor tab, this is your telemetry, they're listed over here. And the store, this is all the commands that allow you to store, restore, are listed in one location over here. And so basically the functionality for each of these commands that you saw in configuration or in fault set, all of that functionality is available over here. So you can change these commands. I mean, if they're writable, you can change the value and write it, and so forth. You have over here on top, you have these two checkboxes. The first one is force hex. If you select that command, then each value of all the commands gets converted to hex values. Sometimes it's easier to look at certain commands as a hex number as opposed to integer or double, and vice versa. Some other commands, it's better to look at them as a decimal. For example, you're looking at voltage, you want to see 1 volt. You don't want to see this doesn't mean anything to anyone. The next checkbox is packet error check-in. If it is a requirement for you, or you want to use packet error check-in to send command to make sure that command is sent correctly, then you can check the use PEC. And when the packet is constructed, the PEC is computed and it's tagged at the end and sent along with as part of the packet. On the right-hand side here, there's these inventory commands, manufacturer ID, manufacturer model, revision, and so forth. And these are standard Pmbus command that have specific sizes, and the manufacturer can change these commands sizes depending on what they need, but they still have to adhere to the Pmbus standard configuration specification. Over here, this is a specific command for MAX 15301 strap disable command, and it shows all the different flags for this command. Again, here the fault tab shows all the different faults. The first one here is a checkbox. It's clear fault. It's similar to the clear fault we saw in the dashboard, the button there. So when you have a fault and you fix the fault, you can send a clear fault over here, and then it will clear the fault for you. Over here, there is like all the different commands that have to do with faults for your vout, for your iout, for temperature, for vn, and then over here you have the status commands. These are the ones that have the different bits that could raise the fault for example, for over voltage or over current or under temperature and so forth. The next tab is the monitor. This has your telemetry, same thing as in the dashboard. There are multiple places where the information is duplicated, and just the reason for this just to make it easier to use for the user, so they won't be switching back and forth. The store command, as I mentioned before, has all your store restore commands. And for example, you make changes to certain parameters, and then you want to store, then you select the appropriate command. If you want to restore, then you select restore and so forth. Again, for storing and commands, your device has to support that functionality. For example, if a device has only a limited number of stores, for example 5, and if you already used all of them, if you make changes and you go ahead and try to store again, it's not going to happen. The next tab is the permissions tab. This applies to the MAX 15301 only. Other devices do not really support this function. This is a standard Pmbus command, and you can go to the Pmbus spec and look at the definition for it. Basically, what this allows you to do is to lock commands one at a time. For example, let's say you created a design and you have one of the commands set to a specific value, and you don't want the end customer to change that value. You can lock the command, and that value will stay there, and unless the end user has the password to unlock that command, they cannot unlock it. The last tab is the Tools tab, and this was created kind of like a standalone way of sending commands to the devices. When you are in different tabs, communication is always happening because the GUI is reading from the values of the Pmbus commands from the device itself. When you are in the Tools tab, there is absolutely no communication. Everything is halted. And you see over here, select Pmbus command. This has a list of all the commands that are supported for that device, and you can select the command, you can read it, you can change the value and write it, and so forth. You can do this one command at a time, or a little bit later I'll show you how to do it using a script. Over here also we have the force hex, so you can see the values both in hex and in regular values. Another feature we have here is the ability to send multiple commands and verify that those commands have been written correctly. And the way to do this is through creating a script. Before showing you how to create a script, I'm going to go over this save configuration as a script text file first. When you select this button, a file is created, and I have one that is already available over here that I'm going to show you. So this is the file that has been created. It has a snapshot of all the commands. Anything follow that has a hash before it is basically a comment. You see over here the address of the device, and then the first column is the command code. And second column is the type of transaction. Is it a write byte, write word, write block, and so forth. And over here is the data that's being written on the third column. And then here to the right-hand side, following the hash, is the name of the command. So you see all the commands here. I'm doing all the writes over here. And in the next section, so this is the configuration section, and in the next section is the verification section. Basically, you read in each of the commands that you have written, and then this is the expected value, and then you can just see that the values are the same. So the reason I did this is as a guideline, so when you create in your script, you can follow this this scheme. Okay, so I'm going to close this file. The way to create so you can, using that file, you can just use the editor and hold on. So you can make a copy of this file, use the editor, and do your changes and create your own script if you know exactly what you need to write, what commands and what data. Another way to do it is to do it on the fly over here by selecting the record button. Once you do that, it prompts you to enter a file name where you want to save the script. I'm not going to do it since I already have a file that I created. And then you can come to the drop-down box and select the commands that you want to write and enter the data over here and then select write. You can do it multiple times for the same command, for multiple commands. You can do a store user all. You can do all kinds of commands. And when you're done, you select stop. Once you select stop, the file is created. And here's a file that I created before. It's a very short one. All I did is, the address is always written, so I didn't select to write the address. Anytime you create a script file, the address is the first thing that gets tagged, put in there. What I've done is I took the vout command and I wrote it 3 times. I just changed it by a little bit, and then I did a store user all at the end. And typically, this file, you can add comments to it by putting a hash and follow like the name of the command or whatever notes you want to add to it. This file over here, or any other script file you create, you can come over here to this location, and then you can add it. It's just like browse, select the file, and then you can run it. And when you run it, it runs through all those commands. Another feature you can see in the Tools tab is the Diff Utility. This is a very simple comparison tool for files. You see over here I have selected a couple of files. I already selected them. And then you select compare, and you get the 2 files side by side, and it gives you the differences between them. You can do this with the third-party utility. There are some sophisticated ones out there, like WinMerge, Beyond Compare, and they're pretty good, and they compare a lot more files than this one. But this is meant for the script files and configuration files, and it works pretty well, and it's part of the tool, so you don't have to go outside the tool to get a Diff utility. Now that I'm done with all the different tabs, I'm going to go ahead and visit different devices. The MAX 15303 is very similar to MAX 15301, so when you select it, you see the same tabs, pretty much the same functionality. There is a difference in the commands that are supported by that device, but all the functionality is pretty much the same. The MAX 2754 is a little bit different. There is no support for the permissions. As you can see over here, permissions tab is missing. But other than that, there is a configuration tab, so you can see pretty much similar layout. There are some commands that are missing. There are some functionality like the advanced configuration and this user calibration that do not apply over here. So basically that's how it works. anything that applies will show up in the configuration, and other functionality and features will be skipped. The monitor is pretty much the same. You see your plots for V out, V in, temperature, and I out. The fault set, again, you have different sets of commands. Some are the same, some are different. All of this stuff will be defined in the application note or user guide for the specific device, because you will see all what's supported and what's not. And you can see all that in the Pmbus Command Tab. You can look at the configuration tab and see all the commands that are available. Similarly with the fault tab. In the monitor tab, typically that's your telemetry, and store command, your store commands, and other is basically commands that do not fall in any of the other categories. The tools command is the same in all of the devices. The only limitation is basically what commands are supported by the specific device. The MAX2743, on the other hand, is a very simple device. It doesn't have a lot of things to configure. As you can see in the Pmbus Command Tab, there's a handful. There's like 5 commands that you can change. Some of them actually are not even changeable. They have one set value. The faults command, the faults tab has all your status commands and clear fault, so there is nothing to change over here. Monitor, this is typically your telemetry, and store. There is no store in this supported in this device, since it's an OTP device. You cannot write to it. And other is a few other commands that do not fall in the other categories. In this section here, you see these 2 commands, MFR DevSet and MFR DevSet2. These are manufacturer-specific commands for this device, and each of these commands is 2 bytes, and inside these commands there's multiple bits that constitute different parameters. And what I've done over here is I put a list of those parameters, and I put a drop-down box for the possible values for each of those parameters. So when you select anything over here, the whole command is recomputed and the value is shown over here. So for example, see, I'm going to change this to 20 amp, and you see that the value has changed. You can see it in hex. And hex, in this case, will give you a better idea. If you go and look at the application note and see the MFR DevSet laid out with bit by bit, then you can see if this is bit 2 or 3, you can see which value is changing. And the same thing for the MFR DevSet2. Again, these are similar to other devices, saving configuration for this specific device only and load into this device only. This feature over here, we needed a way to scale the vout command, and there was no command available to do that, so we elected to do it via software. So we use this resistor divider ratio to scale the command, but this is not savable. So once you cycle power or close the GUI, you'll have to do it again. So this is not something that is saved in the part, and then you can start the GUI and get back to your previous state.
This concludes the Maxim Digital Power Tool GUI demo. For further information, please visit maximintegrated.com. Thank you for watching.